Okay, scholars, now here we have another one of those like circle of deaths or something like that. You will guarantee have a section like this on your test. It won't be as long as this because I want to shorten the test just a little bit, but you're still going to have to show me work, and also make sure you read directions carefully, because right here, look what it says. The angles are marked to specify which angle measure is being asked. They do not represent congruence. Show your work. So I expect if anytime you divide by 2, unless they're vertical angles or something, I've got to see your work. And the next thing you should do is always label everything that you're given. All right, they tell you that line AH is tangent, so it's touching once. But they also tell you the following. The measure of arc AB is 50 degrees, so I plug it in. The measure of arc BC is 60 degrees. The measure of arc CD is 100 degrees. The measure of arc DE is 20 degrees. And the measure of arc EA is 130 degrees. And then we just go through just like what we did before. And actually, by the way, you can have these on the test. Just don't write on them. Or you can grab, I'll try to make sure I have some extra ones. They're going to be over kind of by my metal cabinet over there where I put like the whiteboards and things. Just look above. You'll see slips of paper there you can be using. All right, with this, the measure of angle 1. Well, angle 1's vertex is on the center, so it's a central angle, and it's the exact same as its intercepted arc. So what does that tell us? My intercepted arc is 60 degrees. It's 60 degrees. Then I look at angle 2. Its vertex is on the circle, and so that means I'm half its intercepted arc, so I'm half of what you see there is 50. I can make sure I hold my papers there. Be 50 degrees. So I just go 1/2 of 50, and I just say there 25 degrees. Not a big deal. Angle 3, where's its vertex on the circle? It's half its intercepted arc. Its intercepted arc this time is going to be 20. So you can even go like 20 over 2 if you want, and that's going to be 10 degrees. Angle 4. Its vertex is on the inside, but not on the center, so I have to use the vertical angle and angle 4's intercepted arcs. So I'm going to have a 50 degree arc, and I'm going to have a 20 degree arc. So I'm going to have to go 50 plus 20 all over 2, which is going to give me 35 degrees. And then angle 5. Its vertex is on the circle. That's a chord tangent one. It's half its intercepted arc. Its intercepted arc is the 50 degree arc. It's just 50 over 2, or 1/2 of 50. Again, 25 degrees. The measure of angle 6. A lot of people miss because they're not looking for the angular amount, but the measure of angle 6 is this angle right here. And if you notice, BE is a diameter, and it intercepts the whole semicircle, which automatically means it is 90 degrees. But if you forget that, you can go 180 over 2 as well. Where's angle 7? Its vertex is on the outside, which means you have 2 intercepted arcs, and you take the difference of them. I have my larger one, which is 110, my smaller one, which is 20. So I'm just going to go 110 minus 20 all over 2, and that's going to end up giving me 45 degrees. Angle 8. The vertex is on the circle, so it's half its intercepted arc, so half of 130. 65 degrees. I look at angle 9. The vertex is on the circle. It's half its intercepted arc. Its intercepted arc is 130. So it's 130 over 2, which is 65 degrees. And then you have angle 10. Its vertex is on the circle. It's half its intercepted arc, which is 110 over 2, 55 degrees. Make sure you know how to do every single type of these. And also don't forget to take the time to really review your notes, because look at this next one. It says the measure of angle A is 3x plus 25, the measure of angle B is 5x plus 20, and the measure of angle C is 7x plus 15. Find the measure of the angles of a quadrilateral ABCD. Now remember, ABCD is considered inscribed. The instant you do that, you should know that your opposite angles of an inscribed polygon are supplementary. So I need to use that to my advantage, but I also need to plug this stuff in. So this is 3x plus 25. B and D are going to end up being my opposite one, so I get 5x plus 20 oops, I just put 5x plus 20 in the wrong one. 5x plus 20, get rid of that. And then my angle C is going to be 7x plus 15. All right, A and C, I know the measure of both, so I can plug those together. So I'm going to go 3x plus 25 plus 7x plus 15 is equal to 180. I get 10x plus 40 equals 180. 10x equals 140. X equals 14. Now I can actually plug and chug and solve for angles. And that's kind of the cool part about it. So for angle A, I'm going to get 3 times 14 plus 25. So 3 times 14, that's going to end up giving you 42, plus 25 is going to be 67 degrees. Now, if A is 67, do I need to plug and chug in for C? No, I know they're supplementary, so I can just go 180 minus 67 and get 113 degrees. Now, I'm going to plug and chug in for angle B because it's supplementary to angle D. So if I know B, I got the information. I can go 5 times 14 plus 20. Well, 5 plus times 14, that's going to actually give you 70. 70 plus 20 is 90. If B is 90, what does that automatically make D? 90 degrees, because opposite angles are going to be supplementary. And then last but not least, I put this one on here because a lot of people still missed it on the quiz. And with that, you need to understand that if I draw in my radius, I will form a right angle. And also remember the radius, if it's perpendicular to a chord, it bisects it. So I know if I can find one of those, I can find the other. So I relabel this, and I notice, oh look, it says triple. 9, 12, 15. Find the length of segment FE. You just got to go 2 times 12, which is 24. Hopefully that will help set you guys up with some examples on how to do these.